Hi there, and welcome to today's webcast. I'm John Gamble, Director of Product Marketing here at Corelight. We'll get started in just a minute. We're going to give people another 60 seconds to dial in, and then we'll get started. And we're keeping it a tight 30 minutes today, so it'll be a quick half-hour webinar. So grab a drink of water, and we'll be starting in about a minute. All right, let's get started. Thanks for joining us today for today's broadcast, How to Find Exfiltration with Zeek and MITRE ATT&CK. I'm joined today by my colleague, Vince Stouffer. Vince, perhaps you could give the audience a quick picture of your professional background.
Sure. Hello, everyone. Vince Stouffer. I'm on the product management team here at Corelight. Spent most of my career as a network and security engineer using Zeek and other security tools, and looking forward to talking today about how to use Zeek to find exfiltration.
Awesome. Thanks, Vince. And as I mentioned earlier, I'm John Gamble, Director of Product Marketing here at Corelight. I've been here for a couple years now, and I've spent my career representing data protection products across the privacy, security, technology, and identity verification spectrum. And I'm pleased today to show you guys some very specific examples of how you can use Zeek data to find exfiltration, as Vince mentioned. So real quick, just some housekeeping. We'll talk about the MITRE ATT&CK framework and kind of level set everyone's knowledge there about how that works and where the exfiltration kind of column and techniques fit in. Then we'll double click on open source Zeek, again, just kind of baselining the audience's knowledge about what that tool is. We'll briefly touch on what Corelight's role is in this ecosystem, just a quick word from today's sponsor, if you will. And then we'll jump to 3 specific exfiltration discovery examples, showing you how you can use Zeek data and insights to find specific adversarial exfiltration techniques. And we'll close for Q&A, with Q&A, excuse me. So if you've got questions, feel free to type them in to your questions panel. We'll see them and hopefully have time to answer them at the end. And today's broadcast will be recorded and posted on our YouTube channel as well as shared afterwards. So don't worry if you're not able to join us for the full 30 minutes today, or if your colleagues would like to see this but weren't able to join, a recording will be made available as well as the slides. So with that, let's get started. MITRE ATT&CK framework. I'm going to guess that most people who've dialed in today are familiar at some level with the MITRE ATT&CK framework, but real quickly, right, there's different matrices that the MITRE organization has developed to help organizations understand adversarial activity and movement, and it's ordered kind of sequentially or chronologically from left to right in terms of the order of attack operations, or kind of the kill chain, if you will, which is kind of a predecessor of sorts to this framework. And MITRE's developed a couple different frameworks, right, for different platforms, for Windows environments and Mac environments and cloud environments, as well as now mobile endpoint-specific environments. And what we're looking at enterprise MITRE ATT&CK matrix. And if we look from left to right, as I mentioned, this is kind of describing how adversaries move, starting with, of course, initial access into your environment, where they get that first foothold, whether that's some sort of a drive-by compromise where you go to a web page that accidentally installs something that on your endpoint that you weren't aware of, and now they've got an initial access foothold on your computer, all the way to, of course, exfiltration, where data is being stolen out of your environment, and the ultimate impact is felt by your organization. One thing I like to point out here is that the first half of this matrix tends to be more endpoint favorable in terms of visibility and defense, and that the second half of the matrix here tends to be more network favorable, because that's where they're moving laterally and communications are starting to emanate from within, but also outside of your organization back into compromised environments. And that's tends to be a more network favorable position to catch that sort of adversarial activity, because they're jumping between endpoints or servers. And those communications, those broad kind of network activities, are something that you're going to be able to more easily find from a network position. And today, of course, we're going to be looking specifically at data exfiltration. And I'd like to double click here and just quickly talk about the topic of exfiltration, right? So in short, this is about data leaving your environment once adversaries have compromised internal systems, and now they're trying to get their target data sets out of their environment and into adversarial controlled servers. And so there's many different techniques and sub-techniques that MITRE as documented here. I've highlighted just two as examples, right? T1048, exfiltration over alternative protocols. So that's adversary is using something perhaps differing from their C2 channel. So maybe they come in and communicate over HTTP with their C2 servers, but they choose a different protocol to actually get the compromised data out of the environment, perhaps like DNS. And I've highlighted here on the right a dark reading article about tips to protect yourself against data exfiltration over DNS. We'll actually look at a specific example in today's webcast. So you're interested in finding adversarial techniques for data exfiltration, but how do you do it, right? Well, there's kind of first two options, right? You can detect that programmatically with technology, with algorithms, with IOCs or signatures or behavioral models or even ML-based models where you're looking for patterns that would indicate data exfiltration in your environment. But the other way you can find exfiltration is by finding it yourself, by hunting, by going out and querying your environment, forming hypotheses about how adversaries would exfiltrate data inside your environment. The MITRE ATT&CK framework offers a great kind of rubric or checklist for how adversaries might do that. And so they actually give you kind of the starting point of a potential hunt. Now, again, this tends to be a more network favorable kind of endeavor if you're looking for data exfiltration in that second half of the MITRE enterprise attack matrix. But where do you get network data to go validate those potential hypotheses about how data is being exfiltrated in your environment? Well, a lot of organizations are reliant on network data types that you see here on the left-hand side of the screen, right? The physical network infrastructure in their environment, whether that's firewall logs or net flow coming off of routers or your file, servers, FTP logs, file transfer protocol logs being generated about those particular appliances that form your physical network. Now, those network logs do provide you visibility into what's happening on your network. The problem is that they weren't, in most cases, designed for security teams, and they certainly weren't made kind of to hunt at a holistic level. Those are logs that are typically designed for very specific use cases that relate back directly to those particular appliances. So it's more IT geared for network performance monitoring or troubleshooting or debugging, right? Your firewall. So your firewall logs are going to contain a lot of information that the IT team might need to debug that particular firewall. Not necessarily useful to the security team, and also probably not capturing information that security teams might be interested in. And the problem at the end of the day is that these logs, they weren't made to hunt. And you might be doing packet capture to supplement your network visibility. And typically most people are doing full packet capture for a few hours, a few days, maybe a few weeks if their budgets can afford that kind of storage capacity. And that'll provide you the answer, but only if that thing happened to occur in the last few hours, days, or weeks. And as we know, incident response is an exercise in reconstructive chronology, and these attacks, the dwell times are typically measured in weeks, sometimes months, and you can't go back in time with PCAP beyond that short window of which you were collecting it, because you roll and erase that data storage to make room for your next set of PCAP. And it's also just not a fast data medium. It's a very manual, Wireshark intensive, picking apart packets and basically deconstructing in a human readable fashion what actually happened at a packet level. So you're not going to get your answers quickly. So if that's kind of the challenge of relying on kind of network visibility with traditional sources, where can you turn for something better? Well, open source Zeek, the open source Zeek Network Security Monitor, is a great alternative tool that can solve some of those headaches that I just described. And I'll turn it over to Vince here to talk a bit about Zeek.
Thanks, John. Yeah, so if also probably most people on the call are familiar with Zeek or have at least heard of it, but let me, as John said, level set a little bit and just make sure everyone understands. If you go to the next slide. What is open source Zeek? Well, I'd really like to think of it as a couple different things. It's a very powerful open source network monitoring framework, and it takes raw traffic in the form of network packets, usually from a span or tap port, and we'll see a deployment slide on the next slide. But it has deep packet inspection and has dozens of protocol parsers, and is event-based. So essentially, it's looking for everything, all the complexity and messiness going on the network. It's distilling that down into specific events, and then it's transforming those events into security data. So the primary output of Zeek that people are familiar with is called the Zeek logs, or those protocol logs. So these are separated by individual protocols and tied together with a unique identifier. So each network connection is going to have a UID that ties it into both the metadata about that connection in the connection log, as well as any individual protocols that are used within that connection. So for example, a file transferred over HTTP is going to have at least 3 or 4 different files or log lines in separate protocol logs that are tied together for quick pivoting. So when you're looking at a particular connection, you now take that UID and you can go from log to log, or searching through all that data in your SIM and quickly identify everything that's going on and get all the data about those protocols in a single search. As well as the protocol logs, Zeek extracts files or carves files from the wire. Can do this at extremely high speeds, and then those can be delivered into a static or dynamic analysis pipeline or stored for just later forensics. And the last thing that Zeek is really amazing at is this event engine that runs Zeek also has a full Turing complete scripting language on top of it. So Zeek scripting allows you to write behavioral, statistical, and pattern-based detections on top of all of those events. And so you can now take, be much more do much more types of interesting detections than just pure signature matching like an IDS might do. And so Zeek is sometimes known as an IDS. Sure, it can do some particular types of signature matching, but what it's really good at is those stitching these behavioral components together. So taking a number of network events and saying, if this happens in this time frame and this happens as well, then I'd like you to take some sort of action. So of course, the open source component is what makes Zeek truly unique, right? This is a 25-year-old project that's been battle tested around the world. It's taught in network classes all over the country and the world, and it's got a huge community of users, thousands or tens of thousands of users who are contributing code, who are contributing things that they've identified, contributing scripts and packages, there's a Slack channel, there's mailing lists, there's in-person events and online events. So a great community that makes makes a huge part of this ecosystem what it is the ability to share and gain insights from others that are using it. So if you go to the next slide, John, we'll just look at a quick deployment. And like I said, Zeek is always deployed directly off of the network using usually a span or a tap port, oftentimes a packet broker in larger environments. It does its processing and then exports the logs and insights out to some sort of other thing, whether it's a SIM or some sort of analytics pipeline or just raw storage that you can crunch through on the command line. All of that's possible. The extracted files also can get sent off. And Zeek's super flexible as well in terms of how it can take in data. So intelligence in the form of IOCs can be easily handled within Zeek to do matching, as well as structured data that is not Intel. So you can take in things like, CMDB information or whitelists or blacklists. All of those can be input into Zeek and then used to help with those detections or enriching the data that's going into the logs. We step to the next page. We talked a little bit about what makes those Zeek logs so special, but again, focusing in on the fact that we have high fidelity timestamps, that UID that ties all of the logs together makes it extremely easy. Instead of saying, well, I need to do, a full timestamp and the 5-tuple, the source address and the port and the IP address of the destination, etc. All of that can be tied together in a single unique field. So I no longer have to look for, this 6 or 8 part thing in my search. I can just put in UID and find everything related to that connection. And now as I pivot through all other connections, I can just add those UIDs to my search and continue finding all the data I need. you jump to the next slide. One specific example then as well of how rich the protocol logs can be in Zeek is the DNS log. So you see an example here. A typical DNS query log that you might get out of something like Bind or Microsoft's DNS server is typically only the queries. It's very thin, and you see an example of this on the bottom. On the top, you see Zeek's DNS log, and so you have the full connection information at the top. You then have the type of query, the particular query, the answers, and any other information that was included in the DNS record. So you have basically a full accounting of what happened during that transaction, the query and the response and everything to do with it. So it's pretty amazing to have all of that for every single query on your network, right? And because this data is so compact and storable, you can go back months or years in time to have all of this stored in perpetuity. So if you have, again, some sort of event or intrusion that happened months ago, and you're really curious to see where this initiated, well, you might be able to go back to the single DNS query that started this entire event by storing Zeek's logs. So Zeek is extremely powerful. I've found in my career it has been transformative in the way that I was able to handle and interpret security information and solve incidents faster. So why don't we jump over quickly back to John to tell you about Corelight and what we do.
Sure. Thanks, Vince. As I mentioned, just a quick word from today's sponsor. So who's Corelight? What's our role in this ecosystem? We make an open network detection and response platform. Open because it's based on open source technologies, notably open source Zeek and open source Suricata, that enable you to make fast sense of your network traffic and derive rich insight, from IDS rules that may come from Suricata, and also all of this great Zeek logging evidence that Vince just mentioned in his overview. So analysts can move a lot faster, make fast sense of the alerts that are coming in, triage them, and also it allows you to build really powerful custom detection on top of that environment, because you can actually start doing custom detection engineering using the Zeek scripting framework that Vince alluded to, as well as to take advantage of community developments because it's an open source community. So we make a fleet of open NDR sensors, so multiple form factors that can meet your network environment needs, whether that's cloud-based networking needs or physical networking needs. We've got a range of appliances that can handle a variety of throughput speeds, as well as virtual sensors and a pure software sensor binary that can run in Linux environments, and also fleet management capabilities, so you can manage all of these things together. So I mentioned just a quick word from today's sponsor. Let's dive into kind of the heart of today's topic, 3 specific examples of how to find data exfiltration with Zeek. I'll start off, and then Vince will cover the next 2. So number 1, let's look at an example of how we could use Zeek's DNS log to look for evidence that an adversary might be abusing DNS to actually steal and exfiltrate data out of your environment. So the problem, of course, is that DNS is, quite noisy. There's just so much DNS traffic in any given environment. It's ubiquitous. It's a critical kind of protocol for kind of internet functionality. And that just means there's a lot of noise for adversaries to hide in. It makes a really great place to hide because there's just so much DNS activity. And in fact, it's so noisy and kind of also critical to business operations that often, security kind of architectures and tooling and even technologies for security perspective will kind of make exceptions for DNS because they're so, they want to avoid impacting DNS functionality because it can have, direct impact on business operations. So sometimes you'll see firewalls, for example, making exceptions for DNS traffic. And that just means that it's ripe for adversarial abuse. And adversaries know this. And using DNS to steal and exfiltrate data out of a compromised environment is quite common. We see it in a lot of different attacks over the last few years. And of course, here it maps back to the specific MITRE ATT&CK technique 1048, subtechnique 3. So this is exfiltration over an alternative non-C2 protocol. So as I mentioned, perhaps the adversary established a C2 connection over HTTP. Sometimes, for example, you see people talking to Twitter services over HTTP to actually send commands from a Twitter account, which function as C2 commands. But perhaps they're going to pivot over to DNS to actually steal data out of your environment. because they don't want to send a lot of traffic, a lot of volume of data over HTTP because they're worried that might set up some red flags. So instead they decide we're going to use an alternative protocol. We're going to use DNS because it's very noisy and we think we can hide well in there. And of course, the data we'll use here is Zeek's DNS log, which Vince covered. It's just a great example of the depth of information that you don't get typically out of some of the IT designed logs that you might be more familiar with in your environment, whether that's NetFlow or a DNS server record. DNS Zeek's log was purposely built for security use cases. So I like to say there's no fat on this log. Every single field in that Zeek DNS log is there because it has security value. And specifically, let's just dive in here. These are screenshots from a Splunk interface. And so let's imagine that as an analyst, you're interested in seeing, sorry, let me just catch my voice there. You're interested in seeing where are people making abnormally long outbound DNS queries from my environment, right? Most DNS queries, if they're human driven, are pretty kind of short text, human readable outbound queries, right? You're looking for google.com or something like that. There's certainly many legitimate use cases for very long outbound DNS queries, right? You see this sometimes with ad technology. You see this, you know, there's a variety of totally legitimate reasons why there would be particularly long outbound DNS queries, but it can also be a leading indicator of someone abusing DNS, because if you're going to be using it to get stolen data out of your environment, you're going to want to, you know, break it apart, but also you're going to want to minimize the amount of DNS queries you're using. So you're going to try to maximize the character count. So you might take, you know, a piece of data, break it apart into a bunch of different DNS queries, but you're going to try to keep it to kind of a minimum set of DNS queries as much as you can. So you're going to try to pack as much information into those queries as you can. So in this particular one example, we're saying let's sort these DNS queries across our environment by length, where it's over 25 characters in query length, which again is atypical for a human DNS query, but it's going to surface kind of the top DNS kind of talkers in our environment. And in fact, we see right here an extremely kind of chatty host who has tens of thousands of records, DNS log records associated with them, where those query counts exceed 25 characters. So that's interesting. What could that be? And if we pivot on the UID, which is that alphanumeric string there you see in the top screenshot, that C5PU7 PUZ, excuse me, string there, that's the Zeek UID that Zeek that Vince mentioned, right? It's the connection-oriented stamp that uniquely identifies connections in Zeek's logging framework and allows you as an analyst to say, great, let me see everything associated with that UID, not just DNS, right? We want to dig deeper. So we pivot there on that UID, and now we're seeing the actual queries themselves. And we can see that they are very strange, kind of long string alphanumeric machine nonsense, right? Humans look at that and we don't see a human readable DNS query. It's potentially ad technology, but it's also potentially someone exfiltrating DNS, exfiltrating your data over DNS. And so that's a great example where we can go from a kind of a broad lens of I'd like to see very you know, chatty and long-winded DNS queries to we actually get to see the content of the query itself, and we can keep digging from there. And this might be the starting point of an investigation that could potentially reveal exfiltration over DNS. Vince, maybe you want to talk about this next example.
Sure, and as we want to give a few different examples of what these would look like, that first one is really based on just Zeek data, right? This is raw data coming out of the DNS logs, no modification to either open source Zeek or Corelight needed. You just start doing those queries in your SIM. The second example here is actually using a script created by the Zeek community to find exfil over C2. And if you go to the next slide, John, this is talking about what is called the producer-consumer ratio. So this is, you know, a well-known concept within security, where essentially you're identifying a ratio from -1 to 1 of whether a particular machine is producing or consuming more data. So in this case, a typical, you know, web browser, whatever, would be consuming mostly all of data and would just be sending out some simple requests. So it would be producing very little data, right? So in this case, a normal web user would be a consumer. whereas a server that was actually sending content out would be mostly taking in small requests and sending out large files and images, etc., and actually producing more content. So the problem here that we're trying to attack is, attackers can use common protocols like HTTP to blend in with the noise. And even using existing servers or clients on your network, right, without being able to discover a new host has arrived or something unusual has happened on your network, attackers can blend in, right? So existing C2 channels can also be leveraged to exfiltrate data as well as communicate. And we talked about the difference between using the C2 channel and something else. But in this case, if we used the same thing and we hadn't noticed that client or that infected host yet, what would happen? So the producer-consumer ratio gives us one way to do that. This is a particular variant of that written by Reservoir Labs that's out there in the Bro script repository that is open source for use on Zeek. And there's other examples of using this PCR in Zeek as well. So it's not specific to this script, it's just an example of how to use it. And so if you go to the next slide, John, this is based off of a fantastic paper written by David Bianco, who used Zeek data and actually didn't use the script, but just used the example ratio and the data to crunch on his own. And what it's showing here is, again, that producer-consumer ratio between -1 and 1 is really just showing whether a host is a producer or a consumer. And that's interesting, but it's only for a baseline. But if you then have a particular event you're investigating or something that's happened that's triggered you to start looking into a particular set of hosts, that's what he's referring to as the dirty PCR. So this is when we have a state change. That's the interesting part, right? When a client that's normally just consuming has now flipped and is producing data, right? In this case, exfiltrating data potentially from your network to somewhere outside. And so using this producer-consumer ratio is a fantastic way to just get data that's already there in Zeek, crunch on it with either an existing package or some statistics, and then show where these outliers happen when these state changes occur. So in this case, you see a link to this, our exfil host, right? So the higher the red color, the more away from that flat line in the middle, you would expect that the state changes are more dramatic. And so in this case, this is a host that went from being a consumer, which is closer to the bottom, to a producer, an exfil host. So just an interesting example of how PCR can be used with Zeek data, and the fact that community has actually already driven the script here to show possible identification of exfiltration hosts using a pretty unique algorithm. If we go to the last example, this is one written by Corelight. So now we're stepping into something that Corelight has spent some time working on. If you go to the next slide, this is actually looking at using SSH. So obviously SSH is a common administrative tool used by all sorts of developers and admins, but of course it's also used by attackers to bypass inspection, to exfiltrate data, and to make a great channel for C2. So Corelight has developed a set of insights around SSH that we call it our encrypted traffic collection. And basically, without doing any decryption, this is looking for particular inferences within those SSH connections. So Zeek already has quite a powerful dissector and protocol analyzer for SSH, which shows things like where the connection came from and what cipher suites were used and what version was used, etc. This goes one step beyond and actually shows, if you go to the next slide, John, we have a set of 25 unique insights, which basically shows all sorts of things from how the client authenticated to what was happening during the SSH session. And in this particular example, we have a way to infer whether there were file downloads or uploads occurring over the SSH connection. And in this case, we can actually also infer whether those were relatively small files, like a profile file, for instance, in SSH, or something large, like an image or a large document. And so again, this is just by looking at the timings and the byte counts of those connections and distilling those into statistical analysis. But this is a particularly fascinating way to look for potential exfil over SSH. So a normal SSH connection from an admin, they might never transfer a whole bunch of large files over a large period of time. But if you were examining a set of SSH connections in your environment due to an incident, and you saw a set of SSH connections with Corelight's encrypted data, analysis, you could see, hey, well, this particular client is actually exfiltrating a whole bunch of large files. That's very unusual, and we should go dig in. So 3 examples there, one of just pure data, one of the community's interest and generation of a script or package around that data. And then the third one is some behavioral insights that Corelight has developed on top of Zeek to highlight exfiltration as well. So those were our 3 examples, and I think we're right on time, but maybe we have time for one question, John?
Yeah, sure. We actually got a question just about the last slide you were presenting, so maybe we can close on that, Vince. So you mentioned Corelight can provide insight around file transfers over SSH. What other kind of insights for SSH can Corelight offer? We don't publish that full list, but if you were curious, you could certainly reach out to us, info@corelight.com, and set up a conversation with one of our account reps who'd be happy to dig into those details for you. I can give one more example. So Vince mentioned small, large file uploads and downloads are 4 different insights that Corelight can surface of SSH. Another one is keystrokes. So we can infer whether it's a human typing over the SSH connection as opposed to a machine connection, which could be useful if you're trying to figure out if a unknown or suspicious connection, SSH connection is a human sitting at the other end or not. So that's another example of one of those 25 insights that Vince mentioned. So with that, I think we are going to close it and keep it to a tight 30 minutes. Vince, thanks so much for joining me today. Thank you to the audience for dialing in. And as I mentioned, the recording will be made available, and we'll post it on our YouTube channel so you can share this with colleagues who weren't able to join but want to see. So thanks so much. And with that, I'm going to close the line.
Thanks, everyone.